is UTP? UTP, or Unshielded Twisted Pair, is a type of Internet cable widely used for local area networks. It consists of multiple pairs of twisted copper wires without any shielding, making it a cost-effective and flexible networking solution. Common Ethernet cable. UTP cables are the most common type of Ethernet cables, carrying data and power signals between network devices like computers, routers, and switches in homes, offices, and data centers. Versatile connectivity. UTP cables enable reliable data transmission for a variety of network applications, from basic internet access to more advanced IP-based systems like VoIP, surveillance, and building automation. Types of UTP cables. First is the solid core UTP. Solid core UTP cables have a single continuous copper wire running through the center. They offer superior performance and are commonly used for permanent installations. Number 2. Stranded UTP. Stranded UTP cables have multiple thin copper wires twisted together. They are more flexible and suitable for patch cables and applications with frequent bending. Number 3. Shielded UTP. Shielded UTP cables have an additional metallic braid or foil layer that shield the internal wires from electromagnetic interference. This provides better noise immunity. 4. Plenum-rated UTP. Plenum-rated UTP cables are designed for use in air handling spaces such as plenums and ducts. They are special low smoke, zero halogen jacket for fire safety. Advantages of UTP cables. Cost-effective. UTP cables are generally less expensive than other types of network cables, making them a budget-friendly option for business and home users alike. Easy installation. UTP cables are flexible and easy to route through walls, ceiling, and other tight spaces, simplifying the installation process. High bandwidth. Modern UTP cables can support high-speed data transfer rates of up to 10 gigabytes per second, ensuring fast and reliable network performance. Compatibility. UTP cables are compatible with a wide range of network devices, making them a versatile choice for various network configurations. Disadvantages of UTP cables. Susceptibility to interference. UTP cables are vulnerable to electromagnetic interference and radio frequency interference, which can degrade signal quality and reliability. Limited distance. UTP cables have a minimum recommended distance of 100 meters, which can be a limitation for larger network deployments. Security concerns. UTP cables are relatively easy to tap into, posing potential security risks in sensitive networking environments. Durability issues. UTP cables are less durable than shielded cables and can be more prone to physical damage such as kinks or cuts. Crimping basics. Crimping is a crucial technique for securely connecting and terminating network cables. It involves using specialized tools to compress the cable's internal wires and components into a tight, compact connection that provides a reliable data transmission path. Crimping tools and accessories. To effectively crimp UTP cables, you'll need a specialized crimping tool. These tools come in various styles, including manual and automatic options, designed to securely attach the connector to the cable. Accessories like cable strippers and cable testers can also aid the crimping process. Having the right tools for the job ensures a secure, reliable, and connection and help prevent common crimping issues like loose or properly seated connectors. Preparing the cables for crimping. Number 1. Measure cable. Cut the cable to the desired length. Number 2. Strip jacket. Remove the outer cable jacket to expose the inner wires. Number 3. Untwist pairs. Gently untwist the wire pairs to prepare for termination. Before crimping a UTP cable, you need to properly prepare the cable end. First, measure and cut the cable to the required length. Then, use a cable stripper to remove the outer jacket, exposing the individual wire pairs. Finally, gently untwist the wire pairs to straighten them out, making it easier to terminate them onto the connector. Troubleshooting crimping issues. Proper tool connection. Ensure your crimping tools is in good working order with sharp blades and no wear or damage. Cable preparations. Double check that the cable end is properly stripped and the individual wires are strengthened prior to crimping. Connector compatibility. Verify the connector type matches the cable's specifications and approve for use with the cable. Crimping technique. Practice proper crimping technique applying even pressure and fully seating the connector in the tool. The origins of UTP cables. UTP cables have their root in the early days of telecommunications. They were first developed in the late 19th century as a way to transmit voice signals over long distances using a simple, cost-effective design. The key innovations was the use of twisted copper wire pairs, which helped reduce electromagnetic interference and crosstalk between signals. This twist pattern became the defining feature of UTP cables. The evolution of UTP cable standards. First, early UTP cables. UTP cables trace their origins to the telephone industry in the late 19th century. These early cables used a simple twisted pair designed to minimize electromagnetic interference. Second, Category 1 and 2. In the 1980s, the first UTP cable standard were established, known as Category 1 and 2. These were suitable for voice and low-speed data transmission. Category 3, 4, and 5. As data speed increased, new UTP standards emerged, culminating in Category 5 in the 1990s. This offered significantly higher bandwidth for Ethernet and high-speed applications. Category 5E and 6. To keep pace with evolving networking needs, Category 5E and 6 were introduced in the 2000s. This provided even greater performance to Gigabytes, Ethernet, and other demanding protocols. The importance of proper termination. Reliable connections. Proper termination of UTP cables ensures reliable, highly quality networks connections that can withstand the rigors of daily use. Optimize performance. Correctly terminating cables helps maximize data transfer speeds and minimize signal interference for optimal network performance. Longevity. Proper crimping techniques extend the lifespan of UTP cables, preventing early failures and the needs for costly replacement. Compliance. Adhering to industry standards for UTP cable termination is crucial for meeting regulatory requirements and maintaining network integrity. Crimping tools and techniques. Crimping requires specialized tools to ensure a secure, reliable connection. Crimping pliers with their parallel jaws are the standard choice for UTP cable termination. The crimping process involves aligning the cable wires in the correct order, inserting them into the connector, and firmly pressing the pliers to permanently lock the connector in place. Maintaining optimal cable performance. Regular inspection. Regularly inspecting UTP cables for signs of wear, damage, or deterioration can help ensure they continue to perform reliably. Look for kinks, cracks, or frayed ends that could compromise signal quality. Proper storage. When not in use, store UTP cables properly to prevent twisting, stretching, or crushing that can impact their functionality. Coil cables loosely and avoid tight bends or kinks. Cleanliness. Keep cable connectors clean and free of debris to maintain optimal signal transmission. Use a soft, dry cloth to gently wipe away any dirt or dust buildup. Strain relief. Ensure cables are properly supported and strain relieved at both ends to prevent excessive tension that can lead to breakage or disconnection over time. The future of UTP cables and crimping. Advance in cable technology. As technology evolves, we can expect to see UTP cables with even higher data transfer speeds, improved shielding, and enhanced durability to meet the growing demands of modern networks. Automated crimping solutions. The future may bring more automated crimping tools and machines that can terminate cables with precision and speed, reducing the risk of human error and increasing efficiency. Wireless connections. While UTP cables remain essential, the increasing prevalence of wireless technologies may gradually reduce the reliance on physical network connections, altering the landscape of cables and crimping requirements. Sustainability initiatives. Manufacturers may focus on developing more environmental friendly UTP cables and crimping solutions, using recyclable materials and reducing the carbon footprint of network infrastructure.